We now start section 7.2, which is about how to integrate trigonometric functions. In the first part of 7.2, we will discuss the integrating the powers of sine and cosine functions. So we can have the sine or cosine functions separate, or we can have a product of these functions. So we'll look at all the possible cases. So the first thing, we already know what is the antiderivative of sine x, which means when the power of sine is 1, or the antiderivative of cosine x. So with power 1, so remember we are looking at integral power, so we have odd integers and even integers. So first thing we will look in this case is what happens when you have an odd power. So for example, if you have a 3 power on sine x, then we want to see how will we handle this problem. So this can be handled by splitting and writing this the sine cube x as sine square x times sine x, sine square x times sine x dx. Now we can actually apply the Pythagorean identity here and write the sine square x as 1 minus cosine square x times sine x dx. So now you have to decide whether you want to use integration by parts here or whether you want to use substitution. But now look, most often in these problems substitution would work, because remember the derivative of cosine is negative sine and the derivative of sine is cosine. So we say let u or w, I will take, equals cosine of x, then dw is equal to negative sine of x dx, or dx is equal to dw over negative sine x. So that our expression now becomes, so sine cube x dx now can be written as integral of 1 minus u square into sine x times dw over minus sine x. So sine x and sine x cancel out and we are left with negative of 1 minus w squared dw, which can be easily anti-differentiated. If you want, you can think of it as w squared minus 1 and then integrate. So I think that will be easier. So which gives us w cube over 3 minus w, and then we will now introduce the constant of integration. And now we just replace back our w, which gives us 1 over 3 cosine cube x minus cosine of x plus c. So that is our antiderivative of the quantity sine cube x dx. In the same way, if you have to do cosine cube x, you should be able to do that. Next example, we are going to look at cosine square x. So what happens when we have even power? So for that, you have to recall that you have the formula, I think it's called the half angle formula. So if you recall from your pre-calculus, there is a formula. Well, actually we can start with the double angle cosine of 2x. If you recall, there are 3 representations of cosine 2x. Cosine 2x can be written as cosine squared x minus sine squared x, or it can be written as 2 cosine squared x minus 1, or it can be written as 1 minus 2 sine squared x. So we can use these two to actually find out what cosine squared looks like and what sine squared looks like in terms of the cosine 2x. So from the first one, you can see we can get 2 cosine squared x equals 1 plus cosine of 2x, so that cosine squared x is equal to 1/2 plus 1/2 cosine of 2x. So this is one of the half angle formula, and then from the other one, in the same way, you should be able to see that the sine square x equals 1/2 minus 1/2 cosine of 2x. So these are the two formulas that you will be needing, and just have to kind of remember them and use them whenever you have even powers of our sine or cosine. So this tells us that we can write here equal to 1/2 plus 1/2 cosine of 2x dx. Well, the first one is pretty easy. In the second one, you can use a substitution. So first let me split it. I get 1/2 integral dx plus 1/2 integral of cosine of 2x dx. So we let u equals 2x. Then this implies du is 2 dx. So dx will be 1/2 u. So coming back to our integral, which we have to find, we can write it as 1/2 x from the first part plus 1/2 times cosine of u times 1/2 du. So which gives us 1/2 x plus 1/4 integral of cosine of u du. But integral of cosine u is sine u. So we get 1/2 x plus 1/4 sine of u plus c. We now go back and replace the u. So we end up getting 1/2 x plus 1/4 sine of 2x plus c. So that is how we integrate when we have cosine square x. So in the same way, you should be able to do sine square x.